Hello, ladies and gentlemen. Today we're going to talk about surface area and volume of prisms. Okay, so you're definitely going to want something to write with. You're going to need your notes and you're going to want a calculator. Okay, so let's get started. Well, before we can talk about the surface area and volume of prisms, we first off need to understand what a prism is. So prisms are named after the type of base they have. So all of their lateral faces or the sides of the prisms are going to be rectangles. So when we're looking at these, we could consider like a cardboard box. That would be a prism, okay? So we're thinking about something that can hold volume. So for example, here, this one would be called a triangular prism because the bases are triangles. Now, how do I know which ones are the bases? Because obviously it's not laying on a triangle. The side it's laying on is actually a rectangle. So what we say are the bases are the sides directly across from each other that are the exact same shape. So in this example, the sides across from each other would be triangles. So this would be a triangular prism. This one, since we don't know that those bases that are on the sides there are squares, we could say it's a rectangular prism. It might even be a square prism if all of those sides are the same. This one would be a hexagonal prism. Now notice this one is standing on one of its bases, okay, and we call it a hexagonal prism because the bases, the two sides that are exactly the same, are hexagons. This one would be a pentagonal because notice that the sides, even though they're little, they're rectangular lateral faces, and we call them lateral faces because they're the ones that are on the sides. Okay, so again, let's just get a couple vocab words jotted down here. So again, the base is going to be the sides that are exactly the same but are across from each other. Now, when we see these shapes, they might not always be standing on their bases. Okay, so always find the two shapes. So this would be one of our bases and this would be a second base. So you always want to find the shapes that are exactly the same. Those are what we're going to call our bases. And again, they're directly across from each other. Now lateral faces, so lateral faces, these are the ones that are going to make up the sides of our prism. Okay, and then the lateral edges are where those sides are going to connect. So they are color coordinated here, so you need to jot those down. But I would definitely understand that as we move forward because there will be some examples that ask you to find such thing as the surface area of all the lateral faces. Okay, so get some good vocab written down here. I know they're not lengthy vocab, but make sure you understand what I mean when I say base and what I mean when I say lateral faces. So for starters here, let's talk about the surface area formula we have for a prism. So here is the formula that we have for surface area of a prism. Now it's really good to make sure that we take really, really good notes. Okay, jotting down that again, this is the surface area, SA right here stands for surface area, and that's just going to be the area that's on the surface. So when we talk about a cardboard box, that's just going to be on the outside, what is visible to us as we pick up that cardboard box, okay? So we're finding the area of each different side of this prism. So what we have here is 2 capital B plus PH. Now all of these things stand for something. Again, this SA stands for surface area, and again, this is for prism, so really good notes, be super organized because again, the next couple of weeks we're going to be talking about different surface area. We're going to talk about cylinders, cones, pyramids, and spheres. So this is just the beginning. So again, good labeling here, prism. The big B, so big B, that's going to stand for the area of the bases. Okay? And the bases, again, are going to be across from each other, but another way we say that is those are the things that are going to be between the height of our prism. Okay, so the area of the bases, so that's what big B stands for. P then stands for the perimeter of the base. Okay, and we just have to find the perimeter of one base because it's going to be the same on both the top base and the bottom base. And then H, this is going to be our height. Now the height, it gets a little bit weird because sometimes we might have height on our base shape, but the height is going to be between the bases. So the height connects one base to the other base. And again, of course, height is forming a 90-degree angle. So make sure you understand what all of these different letters mean, because as we move forward, we're just going to work with the letters and plug them into the formula using our calculator to help us figure these out. Now, volume, on the other hand, is the number of cubic units it takes to fill up the inside of a solid. So again, we're just going to stick with talking about prisms for right now. And we just want to figure out what that volume is, or how much that this prism could hold. Now in this instance, if I asked you to find the volume of this shape, you could count all those little squares you see, or you could look at a formula. Now if I were to, a lot of you are probably like, well, Miss Kessler, I do know the volume. The volume of a prism is length times width times height, right? Well, yes, but remember, not all of our prisms are going to be these rectangular prisms. This holds true for any rectangular prism, but it's not necessarily going to hold true as I move forward into, let's say, a triangular prism. Okay, so we're going to jump forward and see what our volume formula is for prisms. All right, so our volume formula, again, the big V is going to stand for volume. We've seen the big B before, and it's going to be the same thing actually. So big B is going to stand for area of the base. And again, just one of them. And then the little h stands for height. And again, this isn't the height of the base, it's the height between the bases. So it's the height that connects the two bases. And maybe if you want to write that instead of between the bases, you could write connects the bases. Because again, height always has to form a 90-degree angle, and we knew that. So now we have two really good formulas. We have our volume formula and we have our surface area formula. And now we're just going to jump into examples using these two formulas and all the variables that we have here. Plug in, type it into our calculator, and find an answer. Okay, so here we go. Our first example here, it gives us one shape, but it's asking us to find the surface area and volume. So I'm going to kind of cut my screen in half here. We'll do surface area to the left and volume to the right. So the surface area formula, if you think back to the notes you took, the surface area formula is 2 capital B plus P times H. And again, we have to remember what all those things mean. So surface area, I'm not going to write SA every time. I'm just going to put in equals. Now I have 2. Again, big B is the area of the base. So now when I look at this, I have to determine what my bases are. Since it's a rectangular prism, the bases could be any of the sides that are across from each other. So I'm going to focus on this side and then this dotted line, the side directly across from it. Even though it's on its side, I'm going to make these two my bases. And again, I could have chose the top and bottom here because they are the same when they're across from each other, but I chose these two because it looks like it is going to be a rectangular prism that's laying on its side. So when I look at this base here, the base shape looks like it's a rectangle. And in order to find the area of a rectangle, I got to think, okay, well, how do I find the area of a rectangle? Hopefully you remember that's length times width. So then I look at this picture and I determine what's the length. The length could be 4.89. And the width, which would be up and down, it doesn't show directly on this one, but if I look across here, it does show over here. So the width of this would be 4.07. So now all I would have to do is grab my calculator. Give me 1 second to do that. I'm going to grab our calculator and you're going to type in 4.89 times 4.07. So I got my calculator, 4.89 times 4.07. And when I do that, I get back 19.90. And I'm always going to use 2 decimal places just to stay accurate here. So 19.90. So that, what I just found here, I did a little bit of scratch work on the side, but that's what's going to get plugged in for my big B because that's the area of my base. So 9.90. Now I'm going to add big P, which again, if you think about big P, what does the big P stand for? Hopefully you remember that's perimeter. So again, it's perimeter of our base. So we have to use the same base we chose to find the area of. And so I'm going to take, perimeter again is just measuring on the outside. So I'm going to take 4.89 in my calculator. 4.89 plus 4.07 plus 4.89 plus 4.07. Type that in my calculator. I actually get back, and I'm going to have to bring my work down here, 17.92. So my perimeter, or my big P, is 17.92. The h then, again, that's going to be the height, and again, the height is between the two bases. So the only number I really haven't used yet is this 6.15. So the height is going to have to be 6.15. So now what I can do is, using parentheses, I can plug that all directly into my calculator. So I can type in 2, left parenthesis, 19.90, right parenthesis, plus left parenthesis, 17.92, right parenthesis, left parenthesis, 6.15, and then close my parenthesis, and get back, looks like I'm going to get back a surface area of 150.01. And again, let's just use 2 decimal places as we move forward here. Now, how am I going to label this? If I'm finding the surface area, how do we label area? Hopefully you guys are remembering that area is always centimeters squared. So always give these a good label. The surface area of this rectangular prism is 150.01 centimeters squared. Okay, well, now we got to jump over and I got to talk volume. So again, we're using the same shape, but now I want to find the volume of this prism. So the volume formula, again, is big B times H. But what's nice about doing the scratch work and keeping your scratch work is some of these variables are the exact same. So again, we already found the big B over here when we were finding surface area, and that was this scratch work down here. So instead of finding the area of the base again, I can steal this number. I already did the hard work. I'm going to steal that number and I'm going to put it in for big B, 19.90. The little h then, again, that's the height, which is between the two bases. So that's going to be the exact same here between these two bases, and that's going to be 6.15. So volume is a little bit easier now because I got to steal from my work previously. And again, I'm going to type that directly how I see it into the calculator. Left parenthesis 19.90, right parenthesis, left parenthesis 6.15, close that parenthesis. And when you get back, you should get back a total volume of 122.39. Okay, so 122.39. Now, how am I going to label volume? Again, volume is what's filling up the shape. So can it just be centimeters squared? Well, it's not area. So if you think about volume, volume is cubic. So we always do cubed units, okay, because it's 3-dimensional. That's why we use cubed. Okay, so again, surface area would be centimeters squared and volume is going to be centimeters cubed. And again, I might be talking a little bit fast, but I'm trying to avoid making this video super long. Okay, so if you have questions, jot them down and we'll discuss them this week. All right, so example 2 here, we want to find the surface area and volume of a triangular prism. So again, I'm going to split my screen into 2 different parts. I'm going to do surface area over here so I have a little bit of more room, and then I'll do volume on the left. So again, surface area, if we steal our formula, is 2 big B plus PH. Okay, so again, we got to figure out what the big B, the perimeter, and the height is. Okay, so again, if you notice, this is a triangular prism, so our bases are going to have to be those triangles. So I got this triangle right here, and then the other triangle directly across from it. Those are going to be my 2 bases. So again, this prism is not standing on its bases. It's actually standing on one of its lateral faces. Okay, so again, the bases are the 2 shapes that are exactly the same across from each other. So I need to find big B. So what is big B again? Again, big B is going to be the area of the base. So since my base is a triangle, I have to do some scratch work here. So this is my scratch work. The area of a triangle, I have to do base times height divided by 2 because it is a triangle. Okay, so what's the base of that triangle? Well, it looks like the base of the triangle is 15 times the height of the triangle, which is 12, all over 2. So now when I type that into my calculator, 15 times 12 equals divided by 2, it looks like the area of that triangle is 90 meters squared. Okay, and again, we were doing this scratch work down here because we were trying to find what big B was, and big B stands for the area of a base. So I just found that the area of a base is actually going to be 90. Okay, so then I jump onto P. Well, what's P again? P is perimeter of the base. Okay, so again, we have a triangular base here. I got to find perimeter, and perimeter is the distance around. So it looks like I have 2 known sides, but I don't know this third side. Well, if I have 2 sides of a right triangle here, how am I going to find that third? Hopefully you're thinking the Pythagorean theorem. So again, we're going to have to do some scratch work. So C is going to be my x squared equals 15 squared plus 12 squared. So I have x squared equals 225 plus 144. Now 225 plus 144 gives me 369. To get x alone, I take the square root. So the square root of 369 is going to be about 19.21. And again, let's always use 2 decimal places. So what I just found here was the hypotenuse of this base of our triangle, and that's what's helping me to find my perimeter. So again, if I were to add those all up, I'll take 15, so I'll take the base of my triangle here, plus the 12, plus the 19.21 that we just found, and that's going to give me a big P of 46.21. Okay, so my perimeter again is 46.21, so if any part of that was confusing, jot that down so we can get those questions answered. Lastly, I got to plug in for little h, and again, little h is between the 2 bases, so the only number left to use between the 2 bases here, between our triangles, is 9.4. So 9.4. Now that I have everything plugged in, I can use my calculator using proper parentheses. So I type in 2, left parenthesis 90, right parenthesis plus left parenthesis 46.21, right parenthesis left parenthesis 9.4, close my parenthesis, and it looks like I get a surface area of 614.37 meters squared. Okay, so again, the bottom part here is just some scratch work I did in the middle of my problem to help me plug in all of these unknown variables here. Okay, so let's jump over and do volume. Again, our volume is big B times H. Let's again steal some work over here from our surface area. So big B we already found, and again, if you remember, that's this scratch work here. So the area of the base is going to be 90. And the height, again, that's the height between the bases. So again, it's between our 2 triangles. So that's going to be that 9.4. So again, type it into your calculator exactly how you see it. And you should get back an answer of a volume of 846 meters. Again, volume is cubed. So I know I talked a little bit fast through these examples, but if you have any questions, make sure you jot those down and we can address them when I see you. Okay, so I want to thank you for taking good notes. Make sure that you have a good notes to refer back to as you're working on your assignment, and good questions for me to answer if you have any. All right, so thanks for taking good notes. I will see you when I see you.